Hi guys and girls on YouTube. In this video we're going to be taking a really quick look at a small TV. It's a Kolster Brandes KV. I'm not just sure what size it is. It measures about 11 inches across. There's no model number on the back, although I do think I have another one of these somewhere, and I've got the service manual with it, which will tell you what model it is, but there's no model on this. But it's not in the best of conditions. I don't know if you can see the cabinet. It appears to be like a green colour, but the actual plastic, if you look at that, it's disintegrating. I can just scratch the plastic cabinet and it disappears. So over the years it's probably undergone some sort of chemical change, and this is disintegrating, and that's the reason we're only going to take a quick look. We're not going to do anything to it. I'll power it up slowly with a variac, and if it doesn't come on, it's going back on the shelf. But at least you can have a look at it. It's dual standard 625405. Now I've already had a quick look inside, and it's horrendously complicated, and that's why I said we're going to be powering up with a variac, because I can't actually get to the main smoothing cap to reform it. And if it doesn't come on, the back's going on, it's going straight back on the shelf. So let's stop the camera while we take the back off. Well, actually, just before we take the back off, let's have a quick look at the back view. That's the plate there, where I would have expected it would have said the model, but it doesn't. It's a 2-pin connector. I've got the original mains connector, UHF, VHF. That's the UHF tuner at the back. If you look there, it's got the same. You just flick that and the cabinet's just crumbling away. So yeah, let's get the back off it before it falls to pieces. Right, well actually I've got the back off and I can see a model number on it. So if we go around to this side here, it actually says there KV003. Now I'll move slowly round. I'm not just sure it's either 11 or 12 inches, but to be a dual standard set, to pack all that lot in, to smush a small cabinet, this is going to be horrendously difficult to work on. And that's why I say if it doesn't come on, the back's going on, it's going back on the shelf. So if I tilt it forwards, you can see how difficult it is to actually get to anything. The valves are on the other side. I don't know whether that's the line hole control, that trimmer capacitor, compression trimmer. You can see them blue caps don't look original. They look like they've been replaced at some time, and there's some radio spares, tight resistors there that have probably been replaced. That's the line output stage. The line output transformer's buried down there. That's a side view, looks like part of the IF. I'm not just sure what that capacitor's for, but it's not the main smoothing. I can see that underneath. So if we just carefully lie it down, like that, and then we take a look on the underneath. The underside of it's just as complicated. That's the system. That system switch is about the only thing you can actually get at. The main smoothing can is right under there. You can see TCC. So what we're going to do is just power this very slowly for a few hours from a variac, and then see what happens. But as you can see, the complexity of it, any work you had to do with this wouldn't just be a 5-minute job. So let's power it up. I've also noticed something else with it, a modification it's had at some time. I don't know if you can see that. Now when the camera comes into focus, a piece of wire soldered across the fuse holder. Definitely not safe that, but we're running from an isolation transformer, and we'll be powered from a variac, so I'm not going to worry about that too much. But yeah, so there we go. Stop the camera. let's get connected to a variac, and I'll come back to it in a bit. Right, well, a few hours later, it's looking good. We're running full mains now, 100% on the variac, but I've noticed there's no picture. There's a humming on the sound, and there's a lot of hiss. So it's looking good, but there's no picture. And if we take an insulated screwdriver, there's no spark at the boost diode, and there's no spark at the line output valve. Now, I've had a look around this, and what I've noticed is here, there's a valve that's not lit up. All the other valves are lit up, but this one, if you can see there, this one isn't lit at all. Now, I've taken it out, and I can actually see what the problem with it is. So I've measured the heater pins for continuity, and there is continuity, but it's not lit up. Now, all the valves are in series, so it's got to be the valve itself that's faulty. And when I've cleaned it all up, I've actually rubbed one of the numbers off, but I think it's a PCF802. I think it is anyway. But if we take a look at the top there, the getter smudge is actually disappearing. So it's got to be that this valve has lost its vacuum. You can see where the getter smudge used to be, but instead of being black and silver, it's like a very greyish colour. It's almost like it's losing its vacuum very, very slowly. So I'm guessing it's a PCF802. We're just going to put an 802 in and see what happens. Well, if you look at it, the internal construction, it looks the same as a PCF82, so I'm assuming that's what it is. And if you look at the getter smudge on the new one, it's all black and silvery, whereas on this one it's gone like a light grey. So almost certainly that valve is faulty. So let's just put the PCF82 in and see what happens then. Well, guess what happened? Absolutely nothing. The TV's still not come on. The only difference is now the valve's lit up, but there's still no activity in the line output stage. So I did say if this set wasn't going to come on, I wasn't going to do anything. I was going to leave it. But I'm a bit intrigued now that we've got this far, and it's obviously a very simple fault. So I did say I was going to put it back on the shelf, but I'm not. I'm going to stop the camera, I'm going to look for a circuit diagram, and we're going to come back to this and fix it. Right, well, I've looked through my radio and TV servicing books, because I've got the year from the internet, 64. So here in the 1964-1965, I've got the diagram. It says there, Featherlight model KV003. Now it's very small to see. So also I've had a look through my vintage ITT service manuals, and I've actually found one here in the back, a VC11, which is, it appears to be a slightly different model, but it's around the same time, 64, 65, and when you look at the diagram, it is actually remarkably similar, and also it's a lot easier to see because it's bigger. So I can see now what the first mistake I made is, just assuming the valve was a PCF802, when it isn't. It's actually a PCF80. So if we actually take a look here, I find the mistake I've made now. The valve I thought was the line oscillator valve isn't the line oscillator valve. It's actually V8, the sync separator. And also it says there it should be a PCF80, and I've put a PCF802 in. So now we've got a diagram, and I found out I put the wrong valve in. We'll put the right valve in, the PCF80, and see where we go from there. Right, so now we've got the right valve in, a PCF80, and well, guess what? It still doesn't work. So back to the circuit diagram again. So I've had a quick look round with my meter, and I find that there's a low voltage on grid 2 of the sink separator valve. Now that's actually caused by this 330k resistor. It's actually risen to over 600k. So I've put a new resistor in there, which you can actually see there, and that's made no difference whatsoever. So back to the circuit diagram and we'll take a look at the line output valve. Right, so I've had another quick look round. I've measured some voltages here on the line output valve, the PL81. We've actually got a negative voltage, it's about 58 volt, near enough on grid 1. That indicates the line oscillator's running. But I've actually noticed, and I can see what the problem is now, pin 8 there, the screen grid, that goes through a capacitor and a resistor. That's the screen grid feed resistor. We've actually got no voltage. It should be 180 volts on pin 8 screen grid. I've got no voltage there, so either that capacitor's short circuit or that resistor's open circuit. Now I can see the capacitor, that's easy enough because that's right next to the valve, but I can't see this resistor. It's going to be an absolute nightmare finding this. So that capacitor there, that's the screen grid decoupling capacitor. I've tested that. That is not short circuit, so it's got to be the resistor that's open circuit. Now, if you look in this, trying to find anything here is going to be virtually impossible. So back to the service manual. And if we look at the screen grid feed resistor there, we've had a bit of a breakthrough, because if you trace that resistor back, it goes straight to what appears to be the system switch. So all we've got to do now is look at the system switch for a resistor, 3.3k, 4 watts, so it's going to be quite a big one. Right, so if we look there, that's the screen grid decoupling. The screen grid's also connected to this yellow wire here. Now you would have expected the resistor to be round here, but in fact it's actually nowhere around there. So that's the back of the set. If we move underneath, that's the system switch at the bottom. I'm actually seeing a yellow wire there. Now I've measured that for continuity, and that does go to the screen grid. It also goes to that resistor there, which connects to the system switch. So that is the resistor that is almost certainly open circuit. So I think the best thing to do now is we're going to fit a new resistor, and also for safety we're going to take that piece of wire off the fuse holder and put a proper fuse back in. And because this time I've got a feeling the set's going to come on. So just stop the camera and we'll do them first. Right, well that's the new resistor in. It's a little bit bigger than 4 watt, as you can see, so it's a bit of a tight fit, but it's gone in and it doesn't look too out of place if you look how compact it is underneath. So right, let's switch it on this time. I'm hoping, well, I'm pretty certain now that it's going to come on. Let's stop the camera, set it up. I've changed the wire link for a proper 1 amp fuse time delay. Let's turn it on then. Right, here we go everybody. It's set for 625, the brightness is up. Let's hit the power and see what happens. Right, power switched on. Yeah, valves are warming up. Taking a long time. And look what's happened, absolutely nothing again. So we're back to square one again. Well, I said we were back to square one, but we're not. Because I've actually noticed now the line output stage is running. If you look at this, we can draw an arc from the line output valve. and also the efficiency diode. So the line output stage is actually running now, so I've got to stop the camera and take another look at this. Right, so the set's actually running. I can hear a hissing noise in the background. We've got EHT, but we've got no brightness. So I've had a look around the CRT, and I find that grid 2 here has actually got a very low voltage on it. Now the manual here says between 45 to 130. Now I've actually measured, and this resistor here, this 4.7 meg, which has returned to the boosted HT rail, I find that is completely open circuit. Now that's the resistor in question, 4.7 meg. It's completely open, but I've also noticed it was down here where somebody's been changing lots of resistors. See, these aren't original ones. These have all been changed at some time. With like a radio spares type. So I've decided that as this resistor has obviously gone open circuit in the past and it's gone open circuit again, it's probably a little bit underrated, so I've changed it from a half a watt to a 1 watt one, and that's the new one there. So and that appears to be the boost capacitor, the boost HT rails down here. So right, new resistor in, let's turn it on again and see what happens. Right, well that's the result. We're cooking on gas now. There's a raster come up and I can turn the brightness up and down. So yeah, let's just get this connected to a skybox now and have a look what the picture's like.
Here you go. Here is
well everybody, what about that? That's a result.
This stuff is just out of date, but it's still okay because it's best before. So
plenty of brightness.
Some shredded wheat. Do feel free.
The local library on the Fitton Hill estate hasn't loaned a single
the height's a little bit down. I'll have to look where the height
Today,
control is. But everything's working. Contrast, brightness.
Over here we have
volume.
an older lady that's told me that she's struggling with the
yeah, what a result that.
Sure she's got enough blankets and warm clothes. And these are for 2 boys and a girl. Their family are just struggling with money, anything to buy them toys or clothes. We're just making sure that they've got what they need at the moment.
So there we go guys, that's the 1964 Kolster Brandes TV. Yeah, alright, thanks for watching, and subscribe to my channel for some more. I'll just give you a shot of it running, all the valves running.
3 children are living in poverty in Oldham.
That's the line output valve, the efficiency diode.
This is Mackenzie.
That's the new sink separator valve.
This is Corby, he's 4, and this is Freddie, and he's 3.
Jessica is an absolute amazing person, but yeah, just
and it's not a bad picture.
Have enough money to get by.
Alright guys, thanks for watching, and I'll see you in the next video then.
Deodorant for Mackenzie. How are you?
I mean, we're not a bad week this week.